Hello, my name is Christina Burgess, and I'm a part of Challenge 2016. And here we have been given three problems to solve dealing with derivatives. So first, we're using the chain rule to find the derivative of f of g of h of a, where h is differentiable at a, g is differentiable at h of a, and f is differentiable at g of h of a. So the derivative of f of g of h of a is going to be equal to, using the chain rule, we're going to take the derivative of the outermost function with respect to the inner function, multiply that by the derivative of the next outermost function at its inner, times the derivative, that is a g, times the derivative of the innermost function. And there is the derivative of f of g of h of a. So we have f prime of g of h of a times g prime of h of a times h prime of a. For our next problem, we were tasked to find the derivative of e to the sine of the square root of x at x equals pi squared. So here we're going to have a chain function. We have a composite function. We have e to an exponent, and the exponent is the function of which is sine of something, and the innermost function is the square root of x. So there we have a composite function composed of three functions. So first, chain rule says take the derivative of the outer with respect to the inner times the derivative of the inner. So here the outermost function is e to the something. Derivative of that is e to that. So we have e to the sine of the square root of x. Now we have to multiply it by the derivative of the sine of the square root of x. So this is a chain function within itself, composite function, excuse me. So the derivative of sine is cosine. Now we have to multiply by the derivative of the argument of cosine because that is the innermost function. And so here I like to rewrite the square root of x as x to the 1/2 power. So here we can use the power rule to find the derivative of x, the square root of x. So here we would bring down the 1/2, keep the x, and raise it to the 1/2, the n minus 1, which is 1/2 minus 1, which is equal to negative 1/2. So here now we can simplify. This would still keep all of this in the numerator, e to the sine of square root of x times the cosine of the square root of x. Now, this negative exponent will translate the base, which is x, to the denominator. So we still have 1/2. This 2 is in the denominator. Now we translate x to the 1/2 to the denominator, and x to the 1/2 can be rewritten as the square root of x. So here is the derivative. Now we're trying to find it at the point pi squared, so we just plug in pi squared. So e to the sine of the square root of pi squared times the cosine of the square root of pi squared over 2 times the square root of pi squared. So this pi squared, the square root of pi squared, is equal to pi. So here we have the sine of pi. Well, the sine of pi, if you would draw a little unit circle, here is pi. The sine of pi is 0. So we have e to the 0. The cosine of pi is negative 1. So e to the 0 times negative 1 over 2 times pi. E to the 0 becomes 1. 1 times negative 1 is negative 1, and we still keep 2 pi. So therefore, the derivative at e to the sine of square root of x at x equals pi squared is negative 1 over 2 pi. And our last problem here, we have been given this function, and the first step is to find where this function crosses the x-axis. Well, where anything crosses the x-axis is where the y is 0. So we can just plug in 0 for y here. So now this becomes x squared equals 7. So we can take the plus or minus square root in order to isolate x. So now we have the points where this function crosses the x-axis at radical 7, 0, and negative radical 7, 0. So now we have been tasked to prove, to show how these 2 points are parallel. Well, if something is 2 lines or 2 points, slopes, are parallel, that means that they have the same slope. So now we have been tasked, in order to find if the slopes at these points are parallel, which means they're the same, we must find the derivative of this function at the respective points. So in order to find the derivative of this, we must implicitly differentiate, because this is not written in terms of y equals x something. So we have our function again. Now we're going to implicitly derive. The derivative of x squared with respect to x is 2x. The derivative of x times y is going to be the derivative of the first times the second plus the first times the derivative of the second. So that's going to be 1 times y plus x times dy dx, because we're taking the derivative of y with respect to x, plus the derivative of y squared with respect to x is 2y dy over dx, and the derivative of 7 is 0. So now we must put all the dy over dx terms on one side and all the other terms on the other side. So I'm going to keep the dy's over here. And I'm going to subtract negative 2x I'm going to subtract 2x and y, so they both become negative. Now we're going to, in order to isolate the dy over dx, you can factor them out. And then finally, we can divide. So here, dy over dx is going to be equal to negative 2x minus y over x plus 2y. So here we have our equation for the derivative. Now we can plug in these two x's and y's in order to see if they equal. If they are equal, meaning they have the same slope, then these 2 points are parallel. So we're going to take this derivative, and we're going to plug in the 2 points. So we're going to have negative 2 times the square root of 7 minus 0 over square root of 7 plus 2 times 0. So that equals negative 2 radical 7 over radical 7, which simplifies to negative 2. Now we're going to have negative 2 times negative radical 7 minus 0 over negative radical 7 plus 2 times 0, which equals negative 2 times negative radical 7 over negative radical 7, which simplifies to negative 2. Therefore, since the derivative at these points is the same, that means that these points are, well, the tangent lines at these points are parallel. And the same slope that they share is